So here in the warm-up, I have given you two problems that we need to solve by completing the square. Go ahead, take a few minutes, work on those, and then we'll go over the answers together. In the first one, I'm going to take 12. I'm going to divide 12 by 2. When I divide 12 by 2, I get 6. I'm going to take that 6 and square it, which gives me 36. That 36 is going to be added to each side of my equation. So x squared plus 12x plus 36 will equal 28 plus 36, which gives me 64. Break it down into the square of a binomial. X plus 6 squared equals 64, square root each side. X plus 6 equals positive negative 8. We're going to subtract 6 from each side. So x equals negative 6 plus 8, which would give me 2, or negative 6 minus 8, which would give me 14. So 2 and 14. Number 2, I'm going to divide by 2. I'm going to get negative 4. I'm going to square that and get 16, which gets added to each side. So I end up with m squared minus 8m plus 16 equaling 28. Be careful when I break this one into the square of a binomial. It's going to be m minus 4. Losing my mind. It's going to be m minus 4, and the reason it is m minus 4 is that middle term is negative. Squared equaling 28. We're going to square root each side. So m equals, that's a negative 4. I'm going to add 4 to each side. So 4 plus the square root of 28, or 4 minus the square root of 28, and I end up with 9.3 or negative 1.3 as my two final answers for the second problem. So this is a 2-day lesson on solving equations using the quadratic formula. The quadratic formula is a formula that you're going to have to memorize. It will not be given to you. But what's nice about the formula is it will work for any quadratic equation. So if you're looking at a problem and you can't determine if you want to factor it, if you want to use square roots, if you want to graph, if you want to use completing the square, quadratic formula will solve all of them. So, ta-da, the quadratic formula. It is very simple once you actually get the hang of it. It's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, with a, b, and c being the three parts of our trinomial. A being with the x squared, b being with the x, and c as always being our constant. So looking at the first problem, first thing you have to do is it must equal 0. Okay, so we're back to where our polynomials have to equal 0. So I'm going to move that x over, making it negative x. And you'll notice I put that x right in the middle spot. I like to keep mine in the order, the decreasing order of x squared, then x, and then my constant. So we're only looking at coefficients. So a is 2, b is negative 1, and c is negative 7. The formula, again, is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So all I'm going to do now is plug pieces in where they belong. So the opposite of b is negative 1, so the opposite's going to be positive 1, plus or minus the square root of negative 1 squared minus 4 times a times c, which is negative 7. All over a and 2. So I'm going to start in my parentheses, and I'm going to start working the pieces down. So I have 1 plus or minus the square root. Negative 1 squared is 1. Negative 4, because that's going to go plus the opposite. Negative 4 times 2 times negative 7 is actually plus 56. And that's all going to be over 4. I end up with 1 plus or minus the square root of 57 over 4. And this is basically where we want to stop and break it into two problems. I don't know why my screen keeps turning on me, and I don't know if you can see that my screen's turning on me, but it is. So I'm going to break this into 1 plus the square root of 57 over 4. And I'm going to break it into 1 minus the square root of 57 over 4. And I would actually be plugging these both into my calculator at this point. Please make sure that you do put parentheses around your numerator, because we don't want that calculator to do the square root of 57 divided by 4 and then add 1. Either way, you should come out with answers of 2.1 or negative 1.6. And again, as always, you can check it, but at this point, I am not going to force you to do that. I would like you to go ahead and try these three using the quadratic formula. Remember that the equation must always be set to 0. You have to have that a, b, and c term. In the first problem, we actually only end up getting one answer, which is 4, and that's fine. In number 3, you should have ended up with 0.2 or 1.4. And for the last one, negative 0.25 or 2. If you did not get any of those answers, or you're confused on where I got any of those, please come see me individually. But before you do that, please go back, double check your formulas. Make sure you're following order of operations. Make sure you have all of the right pieces in where they belong. So looking at a word problem, they actually give us the equation, so it's not one of those word problems where we have to write it. We want to know, though, in what year were 4,200 films produced, so that's actually my y value. So I end up with 4,200 equaling 10x squared minus 94x plus 39. I need to get this to equal 0, so I'm going to subtract 4,200 from each side, and that's 3,900. So 0 equals 10x squared minus 94x minus 300. I'm going to plug this into the quadratic formula and simplify it down as much as I can. When I do that, I end up with 94 plus or minus the square root of 20,836 all over 20. That ends up giving me 12 and negative 3. Negative 3 is what is known as an extraneous solution. Big fancy word that basically means we can't use it. Think about the problem itself. We started in 1971. Well, we can't have negative 3 years. Okay? We can't go back to before the data was collected because it would not be accurate. So the negative 3 we can't use. So the only real or true answer is the 12. And the 12 from 1971 plus 12 years is going to tell us that in 1983, 4,200 films were actually produced. Homework tonight is a worksheet. You're going to use 1 through 16 all. If you do not have it with you, you should be able to find it on my website or the team calendar. So we're going to solve these using the quadratic formula. Again, please make sure that you have them set equal to 0 before you go and try to solve them. For the first one, when I solved it, I got 1.77 or negative 0.6. And for the second one, negative 1 or negative 0.25. Please make sure you're combining like terms as you're moving those pieces over. So if, for instance, the first one, A should be positive 3, B should be 7, and C would actually be working as 3. In the second problem, A is going to be negative 4, B would be negative 5, and C would actually be represented by negative 1. So today we're actually not looking at any more ways to solve equations, but we're going to look at the 5 methods that we've talked about and kind of discuss the pros and cons for each. Factoring is when the quadratic can be factored easily. If it looks like it has very small numbers, if it looks like it has ones, that are going to break out nicely for the diamond, factoring is the way you want to go. Graphing is probably the method that you will use the least often, and it really and truly is only when you want approximate solutions, okay? When you just need to get into the range of where the answer might be, because those parabolas are hard to graph accurately even on the graphing calculator. Finding square roots are best if you're given an A and a C and no B term. Also the best when D is a perfect square. Completing the square you can use to solve any quadratic, but is easiest when A is 1 and B is even. So I really only picked the completing the square method if B is even and A is represented by 1, or there's something that I can divide by in order to get B to be even and A to be -1. And the quadratic formula, as always, that's kind of your tried and true method that will work for any equation. So these 6 problems we're not actually going to talk about, or we're not actually going to solve them. We're just going to pick which method we would use. And yes, I know we can use the quadratic formula for all of them. Okay. But the first one, square roots are the best. Yeah, my pen still doesn't want to work. Square roots. Reason being, we have an A and a C term. We're missing that middle piece. The second one is actually better by factoring, because I can actually very quickly pull out a GCF of X. I could use completing the square, because I have the A and the B, but this works quite nicely for GCF and factoring. Number 3, that doesn't look like any nice numbers, so I'm going to use the quadratic formula for that one. For number 4, you could use the quadratic, but it's nice small numbers, so factoring actually works very well. Square roots for number 5, especially since you're working with a perfect square. And the last one I would definitely use the quadratic for again. You could use completing the square because A is 1 and B is even, so it would work very nicely for completing the square. A lot of these methods really and truly are personal preference. Homework tonight, it's not going to be in your workbook, it's going to be a worksheet. Traditionally, I grade this worksheet, so please make sure, even if you have it in front of you, that you check the team webpage to determine whether or not I am going to grade it for accuracy. If you have any questions or need help with anything, as always, please come see me.